Okay, now we're going to get into dividing. Now you have a similar rule for dividing as I showed you with the multiplication, okay? So again, you're, given these two radicals. Again, they're both indicated here with roots of n, meaning your roots do need to be the same. So if you're asked to divide this radical by this radical, then it is the same thing as if you just write it with one big radical symbol and then write the fraction underneath. So if you have a problem written this way, you can rewrite it this way if needed, and vice versa. You may have a problem written this way and you need to take it back to this. So you can write it as one big radical with the fraction underneath, or you can make a separate radical for your numerator and for your denominator. Okay, so on this first example, what you're going to need to do is actually write it as one big radical first. So we're going to have the square root of the numerator divided by the denominator, okay? Now, once you do that, then what you're going to do is reduce, just reduce a fraction like you always have. Reduce whatever it is that you can reduce. So the 7's going to go, of course, into itself one time, and it goes into the 63 9 times. Now, you can also reduce your y's. The y that you have here on the bottom, this one y, will cancel one of these, which means now you're only going to have two of them left on the top. Okay, so let's write down what we've got. If you notice, the only thing I'm left with in my denominator is just a 1. So if that's all you have left in your denominator, remember, you don't have to write it. So you're just going to have the 9, and then the x, and then the y squared. Okay? So it says to divide and then simplify. So the simplifying you do here is actually exactly the same thing that I just finished teaching you how to do. If you look at your list of perfect squares, 9 is already a perfect square. This being to the second power is already a perfect square. And of course, since this is below a 2, there's not going to be anything you can do with this. So you're ready to actually take the square root. So you'll take the square root of the 9 and the y squared. So square root of 9 is going to give me 3. So 2 will go into 2 one time. So that means I'll have y to the first. And the only thing I'm left with underneath is just the x. All right, now this one is already written as just one big radical. See, that was actually the first thing that I did from here to here, is just write it with one big radical. This one's already that way, so you actually have one less step. So what you're ready to do on this one is to do the simplifying. So the 243 divided by 3. That's going to be 81. So 3 is going to go into 3 one time, and 3 will go into 243 81 times. All right, we also have some reducing that we can do here. The 3 k's that you have here, the 3 of these, or all 3 of these, will cancel 3 of these. So like all of these are going to cancel out. If you cancel 3 of these out, that means you're still going to have 4 of them. Okay, so these 3 will cancel 3 of these, but since there's 7 of them, that means there's still 4 more left. Okay, so what I have at this point is the 4th root. All I've got left on the top is 81, and I've got k to the 4th power left on the bottom. Okay, now, your rule says if you've got it written as one big radical, you can separate it up, and that's actually kind of the thought that you would have with this one. So if I were to separate this back up, I would have the 4th root of 81 over the 4th root of k to the 4th. Now, if you look at your list of perfect fourth powers, see 81's on your list. This is 1 to the fourth, 2 to the fourth, 3 to the fourth. So that means the fourth root of 81 is just 3. And your k to the fourth is already perfect. Because see, if you're looking at your perfect fourth powers, something to the fourth power is already perfect. So what you're doing, remember, is you're saying 4 will go into 4 one time. So that means that you're just left with k to the first power. So that's your final answer on that one. All right, one more similar to these. All right, so let's again see what reducing that we can do. So with the 162 and the 6, you can actually reduce by 6. 6 will go into 6 one time. 6 will go into 162 27 times. All right, now you have 1A on the top. So this 1A will cancel one of these out, which means there would still be 2 of them left. Okay, so what I have is the square root of the 27. I've got that on the top. And on the bottom, I have a to the second. All right, so let's split this back apart. Okay, now, these are square roots. So you're going to look at your list of perfect squares. 27 is not a perfect square. Make sure you're looking at the correct list, okay? 27 is not a perfect square, but what you have on that list is a 9, and 9 will go into 27 3 times. Now, you're not going to do anything with a to the second, because if you look at your perfect squares, see, a second power is already perfect. So the square root of 9, see, that's perfect. That's your perfect square. So square root of 9 is going to give me 3. And this 3 is just going to be left underneath. And again, since this is a square root, you've got an understood 2 right there. So 2 will go into 2 one time, which means on the bottom you just have a to the first power.